So this is part 2 of the properties of water, but the reason that I separated this part out from the other is that pH is not necessarily a property of water, but water can certainly have a pH and can affect the pH of other substances, the concentration of water, okay? So it's important to understand, and this again should be a review from physical science. You should have learned about pH and what it means. So a lot of this is a review, but we are taking what you should know and we're applying it to life science. So that's the big difference here. All right. Now this set of notes is a little bit shorter than the last one. It's only a few slides long with one set of questions at the end. And then we're going to watch a video about 11 minutes long, which you're going to have to go back through these notes and put check marks, nice, bold, or bright, or highlighted check marks next to all the parts of the notes that are mentioned in the video. So we'll get to that in a little while. So what is pH? Little p, big H, because the big H means hydrogen. Okay? It's a scale that's used to measure how much hydrogen or the concentration of hydrogen in a solution, in an aqueous solution. Remember the aqueous from the last time, from the first part of the notes? Now, pH stands for the power of hydrogen, or per hydrogen, meaning how many hydrogen ions are actually coming out and floating around in that solution. Because the more hydrogen ions there are, the more acidic there is. And if something's acidic, it has a 0 to 6.9 measurement on the pH scale. Neutral is 7. So right in the middle, you can see on the chart on the screen, as well as the one in your notes, that water, pure water, is right in the middle. And then something that's considered basic has very little or to no hydrogen ions, and that would be from 7.1 to 14 on the scale. So a lot of people get confused here, and they will say, oh, it's acidic, it must have, a very high pH. And that logically makes sense, but it's really not true. Excuse me. Because looking at the scale, you can see that the lower the number is, the more acidic it is. So the strongest acids will have the lowest numbers, and the strongest bases will have the highest numbers. That's what this says. The higher the concentration of ions, the lower the pH. And in basic, the lower the concentration of hydrogen ions, the higher the pH, okay? Now, pH, and this is continuing, this is slide 26 on your note packet for water. pH is considered a logarithmic scale, on a logarithmic scale. So in order to determine the pH, you would have to do some math with a scientific calculator, but don't worry, we don't have to go that far in this class. This is not chemistry class. So, but it's actually not that hard. I taught it, and if I can teach it and I can learn it, then anybody can learn it. So what does it mean to be on a logarithmic scale, or a log scale? That means that every time you change one unit, you go from a pH of 1 to 2, or 9 to 8, or 12 to 13, or 4 to 5, okay? You are changing 10 times, not just one time. So, if you look at tomato juice and black coffee, okay? Tomato juice is not just 1 time more acidic. It's 10 times. And therefore, vinegar would be 100 times more acidic than black coffee. And your stomach acid and lemon juice, which is why it's not good to suck on lemons, because lemon juice is eating away your enamel on your teeth, is 10, 100, 1,000 times stronger than black coffee. So that's what it means to be on a logarithmic scale. And you can see the changes in decimal places here, okay? So times 10, times 10 to the 10 power, not to the 10 power, 10, to the something power, 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way. So using what we just learned, you're going to spend some class time now putting in acid, base, or neutral for the questions, the first few questions. It's clearer in the notes, so do it in the notes. And then just saying which one's stronger, why, how many times one thing is stronger than another, and so on and so forth. Just a little bit to test yourself, okay? All right, and then there's one more page where it continues on your notes. This is slide 28. And you're going to work on this in class today, okay? It's real simple. Just work with your partner to fill in the blanks. And if you have any questions, you can ask me, but definitely work with your partner first. All right, and then finally, the last slide of the notes. I told you the notes were going to be a lot quicker, only a few minutes. You should, you don't have to finish up the questions that you were just working on, because I'm going to start the video right now and you could do the questions afterwards. So as you watch this 11-minute video, I explained this earlier, you're going to follow along. So you're going to go back to the beginning of your notes, this note packet. So pay attention right now. I know some of you are trying to write, but stop writing for a minute. And you are going to just watch this 11-minute video. And he's going to be talking about many of the properties of water that we discussed in these notes. It's kind of a review. It's an 11-minute review. And when you guys submit these notes as one file, as one PDF file on Google Classroom, if you still need to know how to do that, I will show you how to do that. Please don't share it in Google Docs. I don't know, for some reason, a lot of assignments are coming shared to me. I don't know if that's a normal thing when you submit on Google Classroom or not, but I'll figure it out. But sharing is making me have a lot of files that I have to handle, and I don't have any time for that. So so when I'm grading these, is what I'm trying to say, is that I'm going to be looking for these checks along all of the properties. Now, he doesn't mention all the properties so if you just put random checks, I'm going to know that you were just throwing checks everywhere, okay? So they have to be strategically placed next to the points in the notes that we took, okay? All right.